So I will click on it, and we are live now. So oh, the slides are also on. I will click on the enter full screen button, and let me check stream that it is working perfectly. Okay, so we are in the call, and okay, so we are in the call. Okay, yes, audio is also working correctly. So everything is set up, and we just need to start. Uh, ooh, let's give it time. Why she? Oh, I was mute the whole time, and I was talking to all of you. So I was just saying, it is time, and we should start the session.
Hello.
Yes, you're audible. Hello.
Hello. Huh.
Okay.
Good morning to all of you. On behalf of Department of Computer Engineering of Vidyavadini's College of Engineering and Technology, Vasai, I, Mrs. Smita Zawade, welcomes you for all welcomes you all for a fifth day, 1 week online student development program on boot camp for competitive coding in association with Microsoft Student Partner. I extend greeting to our today's speaker, Ricardo Prins. He is joining with us again for today's session. Today's topic is on time and space complexity algorithm analysis. Let me introduce you to our today's speaker. Ricardo Prince is a software engineer and content creator, Microsoft student partner. We are very glad to have you here again for today's session. Now I request our speaker to take over the session.
Thank you very much for the introduction. It's very good to be here again, especially to talk about such an important topic. And this topic is also very difficult to be properly understood due to its inherent complexity. Um, so the reason I chose this picture, and it's often this is how I feel when I am analyzing some of my algorithms, and we often deal with solutions that
Whoa, did I cut off? Hello, Ricardo. Is the problem in my network connection? I don't know. Hey, I think Ricardo disconnected due to some problems. Uh, okay. And in the call, okay. I will call him again. Okay, so I guess he's facing some technical difficulties. I will try to uh, get back to him. Most probably his internet went down. I don't know why. Mm, mm, okay. While you guys wait, I'll just try to contact him on some other platforms. I'm still calling in and uh, uh, receiving the call. Still. Hey, Mm. I guess his whole internet collapsed because he's not online on any other platforms. And while we wait uh, in order to come completely back, no, it's way done.
Yeah, so till that moment, even we can have some discussion if you want, if
Of
what do you
course,
say?
yes, and uh, you know, I just had some things that I wanted to share. Um, I'll just go ahead and share with the audience, and with that you try to contact him and see
Okay,
what.
yeah, I'll try. Yeah, on
Yeah.
it.
So, as of us, our organization, and the people who are involved in this call, mostly me and our team from Mumbai, we are organizing a thing called AI Gaming Workshop. So it is going to be scheduled on 20th of June, and there are some things that are going to be covered over here. It is you have to code a bot in Python, and you know uh, using the Azure Cognitive Services. So you will utilize AI, artificial intelligence, to make a bot, and then your bot will compete against your peers, and if you win, you win a whole tournament. So this is an exciting opportunity for you guys if you are starting up artificial intelligence and don't know what it is, and also you want to get started with the basics of Python. Uh, that's what I wanted to share, and I had in mind, as well as you know uh, the process for this is very simple. You can go over here as our site, that is aigaming.8b.io, and we have it set up over here, and we will just you can just go over and click on this button. It will load up a form. You have to fill up some small details and press submit. After you do that, our team will get in contact with you. And if you are a beginner, we have a different set of course for you. If you are a more experienced kind of a person and who knows what is basic Python and how do you call APIs and stuff, there will be a different route for you. And on the main day, D Day, that is 20th of June, we will have a complete competition where your skills will be put to test. And uh, as I was doing that, Vedant, do you have any updates?
Yeah, he received the WhatsApp message, but he hasn't replied yet. So,
Okay.
yeah. Till that, if you want, you can share the, website of AI gaming, or
Oh yes,
else, yeah,
yes, I will just go on and the
yeah.
whole thing of this program is dependent upon this website aigaming.com. They have a nice little platform where you can code bots and compete against each other. So I did a event back in the last year in November, and we got an awesome response from all over the Mumbai. So we are trying to do that again, and this time, while COVID-19 is going on, we are trying to make it remote, so you can be at your home, from the comfort of your home. You can play this and win it. I don't know. You will get to learn a lot. What you have to do is just go over this site, that is aigaming.8b.io. Register over here, and here is a schedule of what the steps are going to be for the event. Don't worry about it if you don't know, much of it. We will be there for the whole process, and you know, I will share the registration links with the team and Miss so that she can send it to you, and I will try to call Ricardo again. Let's see whether he's picking it. It went abruptly down. He's not online any other. Okay, so I just had a call with Ricardo, and uh, suddenly, due to some issues, uh, his system crashed. I don't know what heavy work he was doing. So he's rebooting it up, and in the next 2 or 3 minutes, he should be back on track. And while we're at it, I'll just share the AI gaming link with you guys, and if you are interested, just sign on that up, and I'm sure you guys will have fun. And let me just pick it up from so, AI gaming. Uh, um, the link. Here is the link, and oh, did Sneha miss left the call for some reason? That might be really wrong. Okay, I'll Like our connection is also down. This is bad. Um, but anyways, I've shared the link with the team. I will also go up and Telegram and do it while we're at it. Mm, so just on Ricardo again and hope for the best. Whoa. Oh, so Ricardo is here finally. You are muted if you want to talk. Just unmute yourself. You are muted. So Ricardo is here, but for some reason he's not able to talk. Okay, I can play your slides. Just send me those and I'll play the slides and you just do the talk.
Hey, I just plugged my headphones here. I'll try to. Yeah, I have to figure out a way to send it to you because the presentation's in my computer.
Okay.
Yeah. So yeah, Google has optic fibers in the whole city. So everyone uses Google, and it never, like, since I moved here, I never had problems. This is the first time it happens. Let me see, how can
Yeah.
I do this?
Okay. I will message you from an account. Just send it over there.
Okay,
Whenever you are able to do it. Okay.
all right.
Mm, and so Ricardo, do you have a? Hi, Ricardo, is back. Is the internet back? No. Oof. Mm, field statistics, yeah. Okay.
Okay.
While everyone is. Let me just play some background music so people don't get bored. That's amazing.
Got enough of every melody, they all sound the same. Yeah, for my broken heart, no remedy. But maybe if you stay,
When is there's lots of noise.
we can get away with it. Cause you
Okay.
make me love
I'll
my
try to.
imperfections, answer all my questions, just to show me what's on the other side of inhibition. No apologies, my baby. How do you do? Cause I'm feeling so good. Ooh. How do you do? Cause I'm feeling so good. Ooh. Oh, my darkest memories now let me fall back. Would you be there, ready to rescue me if I go out of track?
Being broadcasted to
We can get away with it. Cause you make me love my imperfections, answer all my questions, just to show me what's on the other side of inhibition.
guess it's showing the right side.
Make
Maybe.
me love my imperfections.
Okay, can you guys hear me?
Yeah.
Yeah,
Am I
yeah, we
What's
can
audible?
on
hear.
the
Yes.
other
Okay.
side
So
of
I'm not sure at which
inhibition?
point I
Ooh, I tell you
last
do 'cause I'm
I
feeling
was
so
last heard.
cool.
But anyway, I'll just continue from any place, and I'm pretty sure you guys will understand the topic anyways. Because everyone here is so smart watching it. And anyways, it this has all
So why
to
is
do
it
with
so
what I'm
hard
talking,
to
which
let
is
you
scarcity.
go?
So our resources are not endless. So
To
this
let
is why
you
we have to analyze
go.
our
So why
efficiency
is it so
in
hard
order
to
to
let you
better use our
go?
resources. Although this is a concept that comes from the
To let
economic
you
theory, you can apply it to pretty much any field. And it has a special meaning for us software engineers, computer scientists, or whatever name we want to call ourselves, because we deal with two very important resources, which are time
So
and
why is it
space.
so hard to let you
Uh, um, so, yeah, since we don't have a supercomputer at home, and most likely a great majority of us will not have access to one of these in our lifetimes. Yeah, apparently they're getting your music, Ganesh.
Yeah, I just turned it off. It shouldn't
Okay,
make
so yeah,
problem.
yeah. Anyway, continuing here. So our ability to measure this comes from mathematics, number three theory more specifically, and there's the algorithm the algorithms used the theories used to measure algorithms are not a consensus until this day, but we can generally use an approximation, which most of us call big O, the big O notation, which is an estimate that we use to, let's say, evaluate whether we are going to need to be more or less efficient in our approaches. Yeah, this is the formal definition of the big O, which is the OF. This first definition appeared for the first time at the 19th century. I'm not going to go into the mathematics here. This guy on the bottom left is the guy I'm talking about. It's Donald Knuth. This is not his definition. This definition was older than he is, but he's the guy that's pretty much theorized all our approaches today. Not only the big O, but the big theta, the big omnicorum, the big omega, the little o, and some other approaches that are existent today. Most of us will not use any of these approaches, so I came up with a simpler one, which is called my approach. In my definition, which is probably not just mine, but it's a notation that we apply to computer science to classify and compare algorithms according to how their time and space requirements grow as the input size grows. If you don't know what an input size is, please, you should look to another webinar and not this one. It's a measurement of efficiency for algorithms. Yeah, an example, and again, whenever you see this dog, this is probably something important. So this algorithm, it's okay. First, I'm sure we have uh, some people watching. Does anybody know? You can type in the YouTube chat and I can see it. Does anybody know what the big O notation is?
Okay. I will just, Shahid has tried. Yes, he knows
One.
something. So
Yeah, I can
it
see
will be great,
don't worry,
Shahid.
Ganesh. I can read
Okay.
I have the chat window open here. So anyway, um I think I've given an explanation for those who didn't know what it was, and I'm going to try to explain with these examples. So we're basically counting instructions, right? So for example, this instruction, I'm using the C language here. This is going to print the first element of this array. So there's only one first element. So we can say that this algorithm takes a big O of 1, which is a constant value to be executed. The next example, this is a function that prints an entire array. And again, just a brief explanation. Uh, we are assuming a big value of n. So let's say that this array has the impossible size of 1 billion. So since you guys already are familiarized with this, which would be the big O notation for this one, assuming that we're having the worst case scenario here. Exactly, which Tourist 7 said ON. Exactly, O size. That's another possible response here. So it means that this algorithm will take an amount of time which is directly proportional in a linear proportion to the size of the array. So it's easy to understand this because it's a for which will traverse the whole array and it will print an element in each line per size per element of the array. So the next example, we have a nested array, a nested loop within that array. So again, since we have for each element of the array, all the elements will be printed, which would be the O notation for this one. You guys are gonna get it right because you guys are all good and you know this thing, right? Yeah, this is kind of trivial, I know. And the next example, which is a function that's written to calculate the value of a Fibonacci position, the nth number in the Fibonacci sequence for a given integer. And in this case, what is going to be the big O notation? Yeah, this is not as trivial, although it is kind of simple once you understand the logic of the recursion here. So when you look at it, you realize that let's assume, for example, that num is equal to 0. So if it's 0, at the first line of this function, it will return the value uh, it will return a wrong value actually, but let's disconsider this. The guy who wrote this is probably mistaken because he forgot another condition, but let's assume it's number 1. It will return one value, and whenever we add, if it's 2, it will call the function for number 2, number 1, and number 0. If it's 3, it will call for number 3, and then it will call for number 2, and then it will keep going. But anyway, it will go 2 to the power of n. And a couple of slides in the front, I have a drawing that will explain how can we understand this, but it's 2 to the power of n in this case here. And another example here. So for some reason I had a mental breakdown and I decided to write a function that it will print the first element of an array, and then it will print only the first half of that array, and then after that it will say hi 100 times. So which would be the big O notation for this one? I don't know why would someone write such a program, but it's just an easy example. So have in mind that we're considering a really, really, really large number of n, right? So you guys have given me n divided by 2, size divided by 2 plus 100. But think about it. If n is really, 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 really big, exactly. It doesn't matter. 100 doesn't matter. Number 1 doesn't matter. And even the division by 2 won't matter. Ultimately, the limit of this thing when n tends to infinite will bring us an O of n here. And if you want to further down on that discussion, I would strongly advise you to take a look at Donald Knuth's book called Concrete Mathematics. It makes it easier to understand why do we look at these values on an upper bound, and it will also open your mind, and you will avoid saying that sometimes you don't want to use this or that counting sort algorithm because it goes to O to n to the power of 2, because you understand the difference between an upper bound and a lower bound. Anyway, continue on. Remember, so this example was just to illustrate that when we analyze, we think of really, really big n values. So another dumb example here. So I decided to write a function to print all numbers and then all pair sums after that, which would be the big O notation for this example. Yeah, exactly. But why would it be O n to the power of 2 n square and not n plus n square? The answer is correct. It's n square. I just want to understand. I just want to check if you guys understood the principle. Yeah, so exactly n to the power of 2 plus n, when n tends to infinity, it pretty much supersedes n, right? It n won't matter. And the next example, I know these are dumb examples, but they are just here so that we understand the principles on like using the big O notation. So I have a Boolean function that will check if the array contains an element. So which would be the big O here? ON. All right. But why is that? So yeah, the reason why it's because we are a pessimistic group. Exactly. We only think of the worst. Of course, there are analyses in which we evaluate the best case scenario, but since we're trying to compare the efficiency of algorithms, it doesn't matter for us to estimate the best case scenario in most of the cases, okay? In some situations, it can be interesting to evaluate the best case scenario, but it's going to be very, 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 very rare. So yeah, these are graphics and they show the behavior of curves for values of n. So you can see that a constant big O, which is the O of 1, is what we look for. Not sometimes possible. Most of the times it won't be, but this is the ideal model that we'll go for. And on the other opposite, the O of n factorial, the factorial of n, which would be our nightmare. If we have an algorithm that runs on that time complexity value, we should as well either give up on that problem or try to find something more efficient than that. So this discussion could be very, very broadened if we add like discussions about the average cases, but I think this is out of the scope of the exercise, especially because we're dealing with competitive programming, and this would go into a more complex um, area of mathematics, and I think this is not the case here. We don't want to analyze that. But anyway, if we're at n log n, we're okay, I would say, which is not always possible as well. But anyway, so let's work then. And then I will give you guys a few moments to try to write down a simple function, okay? Given two 32-bit sized integers x and n. And the reason I specified here is that I don't want to deal with issues such as stack overflow or anything too intricate here. I just want you guys to write a function to compute x to the power of n. So this function will take two integer values and it will return a value which will correspond to x to the power of n. So yeah, we will pretend that there are no math functions in any of programming languages we know. So yeah, feel free to use, even if you do pseudocodes, it's fine, or C or Java or Python or whatever. For the purposes of this exercise here, it won't matter in which language you're going to code this, but just try to code it real quick. I'm pretty sure most of you guys can do it in a few seconds or a few minutes. So while you guys work on it, I'm just gonna tell a funny story about when Donald Knuth in I think it was 76, he decided to write a letter to a math magazine complaining about the notations. And the problem was that when he decided to go find the sources to contest the, basically what he was trying to say is that people use only the big O, big O, big O, but he didn't find it reasonable. And he even says that in his The Art of Computer Programming. He has a whole chapter dedicated to that. But he found out that there were no sources using other notations. And it took him like a long time. And his letter became famous because he discusses the implications of using two or three different notations for algorithm analysis. Anyway, we have a short and correct answer there. So for I equals 1 to n, for I equals 1 to n, x times equal x. So yeah, this would give the right answer. And Ritwik, which would be the big O notation for that algorithm of yours? Yes, exactly. I have another one here. So this is another possible solution. I mean, we can write like several different ones. I just wanted to write this one because I wanted to use if else. And what about this solution that I presented here? Which would be the O of the big O notation for it? I'm using recursion So on purpose, I've chosen an algorithm that it's even less efficient than yours, than the one you guys chose there, right? But the idea here, uh, having it, you will, it will be more clear on a future example that I'll show. How can we estimate these? Yeah, but the idea here is to show that sometimes we can write very apparently simple solutions, like to this. Rigorously speaking, this would take like a few lines, but this doesn't necessarily means efficiency. Anyway, can it be improved? Yes, it can be improved. So let me give another suggestion here. So how many times are we doing these operations? And in my example, we're doing it a lot of times. Let's say if I had a 2 to the power of 768, I would have to calculate each one of the values like below that, and it will keep growing under 3. And I mean, it wouldn't be efficient at all. So let's try to see if there isn't a way to divide this problem in subproblems. And for some of you, the expression divide and conquer will mean something, for others will not mean anything. But anyway, the idea here is I am telling you guys that there is a better way of thinking about how to calculate a function, how to write a function that calculates a to the power of b. Okay, so I'll give you guys a couple more minutes so you can think about a different way of seeing this problem and thinking about it to try to come up with a more efficient solution. For those of you who watched the other presentation, dynamic programming was something that I briefly mentioned. Divide power into 2, calculate answer, then square the former. Okay, what if we have an even, for an even number? Okay, but what about an odd number? How would it be divided by 2? Good. Yeah, you're on. So we can divide our problems into two problems of the same size, as Ritvik said. So instead of calculating power of A and B, we can calculate power A and B divided by 2 and then use recursion again. So if it's a odd number, I do that. And if it's an even number, I do that other thing. And then for that case, so just to check if you guys have grasped the logic behind this calculation, which would be the big O note of n here, the big O notation.
Solution given by the Turk is, exactly as you did in your solution. It's just that you read your
Yeah,
mind.
yeah, he was onto it. Yeah, these guys are good. So if you look at this, for a huge n here, what would happen is that I take a problem and I divide it by 2. Then I take these 2 and I divide by 2 again. And then I take these other 4 and I divide by 2 again. And then I take this 8 and so on until I have 1 divided by 2 to the power of n. And when that n value tends to infinity, what is the limit of 1 divided by 2 to the power of n? And this is the time where you leave your calculus professor proud. So yeah, for this function, the big O notation is O log n. And whenever we have these divisions, a good example for this is the binary tree. Okay, we have a similar situation. So you guys remember the Fibonacci example, right? In which I had a function that calculated the nth number of the Fibonacci sequence. And I've used recursion for that. And the next slide, I have an example that explains the growth of that function. So if I call the function for f5, it calculates f5 as the sum of f4 and f3, and that goes to the stack. But the first thing that will happen on the stack is that f4 needs to be calculated as well. And then to be calculating f4, the function needs to calculate f3 and f2, and so on. And if you see that, how many times have I calculated f of 2? And I've taken only f5 an example. And if you see at the lines, you have 1, 2, 4, and so on. So this is explaining how and why this big O notation here, it will grow the 2 to the power of n. So if I had a really, really large value, I would be repeating operations over and over and over again. And this would not only take time, but it would take space, because think of it. We need to put these operations in a stack. And if you do this in Java, for example, it will crash fairly quick. In C, there are some workarounds that can be used in C++ as well, but in Java, it's simply not possible. If you use recursion in Java for a really large number of operations, because of the way that the Java virtual machine is designed, your program will simply crash. So the question here would be, how would I do then to calculate Fibonacci of a larger number in a more efficient way? And now I have an invitation for you guys. I know that if you Google that, you can come up with an answer that's fairly easy to find. But the challenge here is challenge yourselves and try not to Google that before you attempt a solution. So try to come up with a way of reducing the number of operations in here. Do we really need to calculate all these f's in order to get the f of 5 or the f of 7 or the f of n, for example? Try to come up with a solution. And I'll give you guys a couple minutes to work on that. And that's perfectly fine if you can't find a solution, because we'll be discussing this together so we can understand a better approach, not for this problem, but for all problems in general. I think I'm gonna sing a song.
That might, get some responses from these kids.
But if I sing something famous, we'll have like 1,000 people watching. I'm a great singer, you
Yeah.
know.
Oh, what is your favorite song?
I can sing many songs. I can sing Baby
Mm.
Shark.
Oh, I've
It's one,
seen you uh, do
eh,
that in the Discord club.
yeah, it's one of my favorite songs.
Mm.
And
Mm.
did I ever tell you that the Fibonacci sequence was discovered for the first time by an Indian guy?
Oh, no. Who's that guy?
Yes, I'll
Fibonacci
tell you
sequence.
that story
Wait,
another
I'll.
day. Ooh, there's a solution. So for I in range n, output append output -1, -2, return output -1. Ooh, that's why I love Python.
Oh, this is Python. Yes. Mm.
Does anybody else have a different solution? That's a very good one. And this one can also be done in other languages as well.
For the past few days, the speakers are just talking in terms of Python. So I think,
Oh yeah, no, a lot of
uh,
people do that. And yeah, I've been challenging myself this year. So I've been
mm,
doing all contest websites possible using Java. And it has
oh,
been tricky, but I've been learning a lot in the process. But sometimes solutions are way easier using Python or even Wolfram, Haskell. I think Farhan sent us a problem in the chat, and I solved it using Wolfram in a very like a aggressive and simple way. And anyway, I like functional languages, and scripting languages are very good as well. But yeah, let's take a look. So what if we store previously valued calculated fn values? And can we get rid of recursion? And Mohit did it very well. So I've used C again, and I've declared an array to store Fibonacci numbers. So I came up with a different solution here. So I wrote an array. So remember when I was calculating all these function values over and over and over? So if I do that, I can solve it because instead of calculating them over and over, I just store the values. And this way I solve a problem, but I create another one because look what I just did. Now I have a huge array storing all values. And remember about scarcity, so our resources are not infinite. So since our time is not the only one, we also have space. My solution is also not very efficient. I commend Mr. Mohit there for his solution because his solution is better than this one that I have presented. So can it be improved? Yes, of course. And I can improve space complexity. And Mohit's solution improves space complexity. However, what about time complexity? Can it be improved as well? And
there was a glimpse
so
of the answer for a second, and then you showed it up.
no, yeah, that's because I wanted to move on to the next one because Mohit's solution pretty much has a very efficient way, which is similar to this approach. And this approach only improves time, the space complexity. You see, instead of storing all values into an array, what I do is I only store uh, the two like previous values, and in here I increase a little bit the space efficiency. All right, but I want to focus on the time uh, complexity now, and I'm giving a hint in the next slide on how can we improve this, because I'm a very cool guy. So the Fibonacci sequence has many cool properties, and one of the cool properties is this one. So if you write down that matrix 1110 to the power of n, you will get a matrix that will contain fn plus 1, fn, fn, fn minus 1. So can you use that information to come up with a solution that is more efficient, um, time complexity speaking? And now I'm going to give another hint. So remember the divide and conquer approach? You can use that divide and conquer approach here too. When I was writing the latex here, because there are like hundreds of different ways of calculating the Fibonacci numbers, and I was going to use another one that is another more complicated property, and I started typing the code and typing the code and typing the code, and then I thought, why am I doing this if I can just write the matrix? And then I chose this one instead of the other one. I think the older I get, the lazier I become.
And the lazier the guy, the quicker he tries to do things, and that often at times ends up in a more better solution to do things. But mostly, I don't know.
Ooh, I have an
But
interesting solution there. So divide it until you're left with n equals 2. Then matrix multiplication for fn position. That looks interesting. That's not how I thought about it. I would do it in a different way, I think. Or not. Oh, you're just don't die. You still have a long life ahead
no,
of you.
no, no.
So yeah, I wrote this one using multiplications in Java because my Java IDE has a lot of colors, and this program I was using to generate the code wasn't so colorful. And I chose green and yellow and blue because I'm from Brazil and I like these colors. Anyway, so yeah, I basically wrote 3 functions: one to calculate the Fibonacci, another one to do the multiplications value there, and the other one to do the matrix to the power of n. And I've used a little bit of recursion there. And when you do that, when you divide that way, because if you do that, if you see down there, I do power in the power method, or should I call it function, just to make it easier. I do power F and n divided by 2. So I divide it and then I multiply again. Anyway, that gives us a O log n, which is a very efficient algorithm. I mean, we can even make this one more efficient. Can we? Yes. In fact, we can make it O1 time and space. So you can look up for the Binet's formula, which is one of the formulas. I'm not going to show it here. It's short, but in order to demonstrate that formula, it would take me like a long time. And the whole idea here was to present a thought process that allows us to try to improve our efficiency. And I would indicate a few readings. The first one is The Art of Computer Programming, which is a book by Donald Knuth, which is a great book. It's a series of books, actually. But these books will discuss in a very profound way algorithm analysis, asymptotic analysis, and efficiency of algorithms. And which is interesting is that some of these algorithms are used in Java functions, for example. And some of these algorithms are used in the way that we calculate numbers and until this day. So this guys, we have someone to owe for not only this presentation, which is a silly and short presentation, but for everything that we do in regards to time and space complexity. We should look this guy. And even if you type it on YouTube, you can find several videos of him explaining and analyzing algorithms and giving classes and lectures. And this is something that I strongly. Do we have any algo for making x to the power of n01? Not to my knowledge. Not that I know of. I think the fastest you can get that I know is O log n. Computers nowadays, they use a different way. I mean, they have several tables embedded into them. So, and they use other estimates and other more complex algorithms. And a curiosity would be to check the source code, for example, for the Java math functions. And you can see some of these algorithms in practice there. You can speed up a little bit, but to the x to the power of n, that I know, you can get a 1. You can get a 1 for Fibonacci, for example, but not to x to the power of n. But anyway, I strongly suggest if you want to get good at competitive programming, you need to get the art of computer programming and the CLRS algorithms as well is a very good one. And if you send me an email, I can send you some of the books that I suggest. Please feel free to reach out to me. And it was I'm very thankful for this opportunity that I've had to present some of these things. And I hope I can see you guys in the future being great programmers and scoring in the competitions. And we're having a quantum Q-sharp competition coming really soon. Try Googling that and participate. And thank you, Ganesh. Thank you all from the Vidya Vardini School as well.
Thank you, Ricardo, for being here. And if Darsh is in the call, I would like to, call him. Yes, it is quiz time. Unmute yourself
Yes, hello, can
and
you
let's
hear
try.
me? I mean, hello, can you hear me? Teams always mutes my headphone for some reason. I don't know why.
Yes, yes, you are audible.
Yeah, so just give me a minute. Let me share my screen. Time, space, complexity. Can you see my board right now? Can you see my screen?
Yes.
One second.
Wait, let me just see.
Time.
No, no, it is not visible yet.
Yeah. Can you see it now? Uh,
Not till, not until. Okay, yes, it is
just
visible.
checking, making sure the settings are right. Not to, because Ricardo is written is slightly differently, so I cannot shuffle the questions this time. So yeah, here's link. I will say it. Um, I'll just share it on Teams. Ganesh, can you share this to the wider population since I'm not on YouTube? Sorry.
Okay.
Yeah, there you go. Do you see the link?
And yes, I see the link.
Can you please
And
share it to the wider population so they can all have the benefits of Ricardo's questions? And Ricardo, don't leave, please, okay? Because I wanted to discuss it this time. Like last time, we made a mistake. We couldn't discuss the answers. Not this time.
no, just for the sake of that thing, because Ricardo was too tired the last time we played this, you know, and it was very late for him. That's why I scheduled this call early today. For Darsh, I don't know what is the time there.
It's 8. It's nearly
Darsh,
9. Ricardo's quiz took enough time, so. Uh,
okay. Uh,
So someone's username is loading. Don't try to confuse me, please. Don't confuse everyone. See, it's often a play just to confuse everyone.
so this question.
If Ricard is leaving or what? Ask me.
Oh, I'll try to call him back. Where is Ricardo? Ricardo has left. Let me just get him back. Oh, he says I need to go.
Even if at most 10 minutes. It won't take more than that really. Like as So maybe 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We'll start now, Ganesh, okay?
Okay, yes. Uh,
Ganesh?
Hey, yes, I'm there. I'm there in the
What
call.
happened?
Nothing. I was just saying. I don't know why I'm so bad at these.
I mean, this time the average is much high, 38%. It's better than we had last time.
Yay. It's better.
What if you press the joining later? I guess once is 47 YouTube, please. Topic. I think you're done actually.
Yes, I think we're done.
I think I should probably end it here. I don't know why it's not.
Ricardo isn't even here. How are we supposed to discuss it?
His loading is very irritating usually, making us think something is loading.
Okay. Ricardo.
There you go. Ganesh, this one was much better answered compared to the average one. Like there weren't any such, fill in the blanks or questions which would be challenging to get right. So I think that's why it was much higher accuracy rate. I mean, and if we take a look at the questions, we can see Ganesh like which are the best answered.
Okay, so this was, the best answer and
What's the best answer?
58% of accuracy.
This one apparently many people got confused. Many people thought it was O of n, but if you have the reference, it's just literally one single deletion. So that's actually O of 1 if you have the reference. You don't have to reference her, it's actually O of n, but you're supposed to assume you have the reference. That's why many people thought it was O of n. And bubble sort, yeah, I guess most of them knew this well, 67% accuracy. And this is another Ricardo's question. It is O of n indeed, not of n log n. There's no sorting happening anyway. Many people got this right. This is a tricky question actually, so I was experimenting to get this wrong. And no one wrote, oh my god, Ganesh. Last time people gave
were you
answers
expecting
like
it to get right? Oh my god.
last time
There was. Yes. What are you saying?
I was saying there were some people last time who gave answers like this. So
Yes. Uh, Blue Cheetah. I guess that was his name.
he got second this time. This blue cheetah got second this time.
Wow.
I in this one people anyway guessed all. It clearly seemed like 3-2-3-3-3-2-2. So this
They
everyone
just
clearly
took a
guessed.
wild guess.
Yeah.
I don't know. I chose the first one, but it was the second one.
Yeah, because they're actually on this.
Yes.
Because A and B have the same big O notation, which you can prove using some approximations. But that's not what we're going to discuss here. Because this, if you just take n by 2 log n by 2, you can show that log of n factorial is greater than n by 2 log n by 2 or less than n log n. And hence they come in the same complexity class. And the big O notation is actually the same. Yeah, this one many people didn't know the answer. Only one person got this right, and that's blue cheetah. This is Ricardo's question.
Wow.
Literally,
I think he took a wild guess. I don't know.
Yeah, I think this most of them knew it's n log n because you're just basically sorting. So that's where the n log n comes from. But most of them got it right. This one also most people guessed, I think, between the first 4 options, and just last one left it blank. No one picked the last answer, but everyone otherwise guessed. Because you're basically looking at every possible permutation.
Oh yes, I was just confused between whether it will be n factorial or n into n factorial. I chose n factorial and then.
And the last one, this I think Ricardo just discussed just a minute before, I think, just a couple of minutes before, just like a few minutes before, right? Ricardo discussed this approach.
Okay.
Right. It's just overlog.
Yes.
If you do divide and conquer, it's literally just overlog n. And yeah, I mean, overall, this is better answer than the previous one. So I guess that's good. I'll send you the quiz report, Ganesh, soon as well.
Okay. Yes, I will send it to Smita ma'am as soon as I get it. So Smita ma'am, just end the session. Yeah.
Yes. Thanks, Ricardo. It was really informative session. In starting, some technical issues were there, but you have handled the session properly. Thanks, Darsh. Thanks, Ganesh. Thanks to whole team of Microsoft Student Partner. And also thanks to all the participants for your participation in our SDP. Tomorrow's session will be at 4 to 6 p.m. Please fill the feedback for today's session. Link is provided in Telegram. Thank you so much.
Thank you, Miss, for being there, and thank you guys for being there. I know this is a tough topic to be, listening upon, and many of the time people get bored, but no worries. You were there with us from the beginning, and for tomorrow, I just wanted to say that be there and bring your friends because we're gonna be having a little sort of a competition. So Dash is gonna design a special little contest, a little competitive programming contest for you guys, and we will be having a speaker who will be teaching you guys how you can utilize a platform. And if you don't know, if you know, then that's good. But if you don't know, you will get to know about those things, and then will participate in that program, and maybe the winner of those things will get some goodies from us, our side. So just join in and make sure you call your friends as well. Okay. Evening at 4, and the speaker will be Harsh Bardhan Mishra. So I hope you have a good day. Take care of yourself, take care of your family, and bye bye.